So Mohammed and Kel, the floor is yours.
Thanks. Hello, everyone. Thank you a lot for making the time to join our talk today. We have a very exciting idea we want to share with you, but before going into that, let's introduce ourselves. My name is Muhammad Adil. I am a structural engineer and a software developer. I started my career as a structural engineer in Qatar, where I have participated in the design of multiple high-rise buildings. And recently I moved to the Netherlands, where I worked as a full-time as a software developer in multiple startup and also corporate business. Kel, you can introduce yourself and tell us why we started this.
Yeah, hello everyone. I'm Kel. I'm a structural engineer and I've been working for Arab for the past 5 years. I'm also based in Berlin. And I'm specifically excited about this project because it really combines my passion for engineering with the passion for programming and software developing as well. And to tell you a little bit of a personal story, why we became so passionate. So one of the first projects that I had some while ago, when I was still quite inexperienced, I was assigned to design all 1,000 columns in this office building near Frankfurt. So as I was asking around my colleagues what the best approach for this was, they told me all you can do is basically build groups depending on the geometry and the loads. And then I would need to design them all one by one in a design program like Freelo, what we use in Germany. So because there was 1,000 columns, it was still 60 different groups. So it was a massive task. It took me about 4 months. And as the design was changing, I had to redo all the calculations. So that really got me thinking that there must be a better way of optimizing this workflow. And I came to the conclusion that programming is the key to this.
Similarly, I also have the same struggles. I was involved in this tower design in Qatar, and a task was for me is to design the penthouse for the owner of this tower on the top floors. So the architect came with me with the layout. I spent almost like 3 weeks designing the floors, the columns, the beams. And at the end, the architect told me we need to change the layout because the client wanted to do so. So I just realized my 3 weeks of work has gone to waste and I need to start over, sketching the model. You know the process, it's very tedious. And believe it or not, after the second iteration, the architect came with me with this question, like, can we have a swimming pool? And I just realized we need to do better. So this is why we started Awatif, and Kel can tell you more what Awatif is exactly.
Yes, so Awatif is basically a platform where we provide web-based engineering apps. And the best way to show is let's jump on our website. So this is our homepage where we sort of document the entire code and sort of tell how this is being used. And if you go here onto the examples, you can see our different apps. So if we jump, for example, into this app, as you can see, it's completely web-based, so it can be accessed just by clicking onto this link. And as I'm playing around, you can already see how light it is as well. So here in this case, we have a 3D structure, and as you can see, we have this point load here. And as this is parametric design, we have these input sliders. So if I change the load, you can see how the deformation increases and decreases. So as you can see, it's very seamless. So we have our own FE solver that's constantly working in the back, and it updates the results automatically. So if we, for example, have a look at the normal forces and realign the visualization, you can have you can see that we have our normal forces, we have tension and compression here in red, and as I'm moving the sliders, you can see that the results is all calculated seamlessly. Yeah, so we have different apps here. In a little bit, I'm also going to show you a bit more in detail our truss designer. But for now, let's jump back into our presentation. And yeah, as I'm doing structural workflows on a daily basis in my work, yeah, I want to show you and tell you a little bit how it's currently done. Basically, what I also explained with my example of the column design, it's a manual sequence of using different programs, meaning you need different programs and different licenses as well. And for each step, basically, you would need to transfer the data manually from one program to another one. So this is obviously very time consuming, and there's a lot of room for errors. And it's also quite expensive as you need a lot of different licenses. And also, once a design changes, you would need to go back into the workflow and do these steps again. So nowadays, this workflow becomes more and more digital. So especially with the help of Rhino and Grasshopper, yeah, these workflows are getting more automated, meaning that that the data transfer is more and more automated and digital. This is obviously a very good development. So the engineer becomes sort of the digital architect themselves. But I'm also using Grasshopper a lot on a daily basis, and I know there's always a risk that these scripts are becoming very complex, meaning that other colleagues, it's hard for them to reuse them. So a lot of the times the scripts are just made for individually one project, and they are not really reused again. So with our Awatif Truss Designer, we aim to tackle these challenges. So in this web app, we try to combine sort of an entire workflow in one program. So let's jump into a quick live demo and show you our Truss Designer. And as you can see, here we have the same interface. We have the same approach of having these input sliders here on the right. So for example, by changing the web type, we can quickly change the geometry. We can change the loads, and as you can see, the deformation shape changes as well. Here, we have a connection designer implemented. Here you can see the color indicates sort of the utilization ratio. And as I have no load, you can see all the nodes are basically blue, which means they are utilized well. And as I'm increasing the load, you can see that each node one by one is failing. Yes, so the biggest advantage and feature that we have implemented into this app is the report function. So here in our report, we can now select a node that might be critical for us to understand. So let's, for example, click onto the node number 5. And here you can see we have a visualization of our node. So we have a slotted plate connection with fasteners. And as I'm increasing the load, it automatically calculates the amount of fasteners that are needed. So you have a clear understanding of how the connection would look like. Here we have an overview of this specific node and the beams and all the informations that you need, and also a summary of the utilizations of the different checks. These checks are documented here in the following. So we have the input parameters, pretty much everything you need to calculate, for example, the spacings, and then the fastener capacity as well. And then lastly, we have the connection design and member design. So everything is documented. So it's not really a black box. You can know exactly what's being calculated after the Eurocode. And if you have a compression force, you also have a stability check here as well. Yeah, another big advantage of having everything within one program is that you have the data stored within one program, which means here you have a big summary table of an overview of each single beam and connection, and the amount of fasteners that is used in each connection as well. And here you have an overview of the checks. That also means that we have the exact quantities for this entire structure. So you have a bill of quantity as well. So in this case, you have used 103 meters of timber, which accounts for this amount of volume. And also you can calculate then the carbon footprint of this structure. Yeah, so by this approach, you have basically closed the cycle of this workflow. We're now thinking of having an export function to export the geometry, the 3D geometry that you can then import into Rhino. So then you have nice visualizations for your report as well. And yeah, so this was our truss designer. I'm going to go back into the presentation and hand it over to you, Mohammed.
So as you can see, this process is not something new, this automation techniques. There is a lot of existing tools like grasshoppers and Python. So why Awatif is different? The main benefit Awatif is web-based. So with web-based, you always have an app that is up to date, it's easy to access. There is a lot of benefit of web-based application. You can just see what Figma did to Photoshop, and we're trying to do the same here. Also, another benefit of using Awatif is a script base if you compare it to Grasshopper. So you will not have this spaghetti model, we call it, when the code got very complicated and only the one who created can understand it. With script base, it's always easier to abstract your concept in different files and function, which are easy to read. And also you can test your code, which enhance the robustness of your application. And with script base, you can also use version control system like GitHub, which enhance collaboration a lot. And also a critical point, the code is reusable. So if you build a script that do the design, let's say for timber column, you can reuse it in multiple projects. So that's also another benefit. And finally, which the point that's aligned with the goal of this organization, it's open source. So that's mean you have full control of your app and there is full transparency. And with open source, we can work together as a collective of effort to move forward. And instead of each company trying to reinvent the wheel every time to doing the same calculation, why not have a repo where it's well tested, well validated, and we can just reuse the code as I mentioned. So there is a lesson that we learned during our process. Parametric modeling is great. It is a hype, as you know, but it has its limitation, and we acknowledge this limitation, which is it does restrict the design space. So you don't have the freedom to design, let's say, the arbitrary shapes you have in mind. So if you see this truss designer that we show, it has this triangular shape. And if you want to have like arbitrary shapes that usually in practice you have shapes that are irregular, then parametric modeling fails. So we are trying to embrace a hybrid approach where we also use manual drawing and combine it with parametric modeling, because with manual drawing you have the full flexibility to design the building you imagine. But manual drawing, it's the bottleneck of the design where most of the time has been taken. So here with this hybrid approach, you still have your manual drawings, but the rest of the, let's say, the outline of this truss, you can put it manually, but the rest of the geometry, let's say what kind of the truss, what is the width of the height, it's generated automatically with parameters. So with this hybrid approach in mind, we are planning next to have a building designer app where if you change the layout of the architect, then the process will be automatically propagated from the geometry generation until the reporting. So that's me getting back to the example I showed with the penthouse. When the architect came back to me with the new layout, it will be a matter of seconds to change the layout because everything is connected. So the load will propagate from the facade to the floor to the connection. And as Kel showed you, we have this full control of the data, then the process can be enhanced dramatically. And this is what we're trying to aim with this building designer app. And we think we can pull it off as we pull the truss designer off. And we already made in a lot of progress, and we are about to to release 5 apps that will be used in this building designer. So if you want to be updated with the latest changes and want to get your hand dirty with our beta version, approach us in LinkedIn, and the best way to follow us is in our LinkedIn page. And it is, if you just type awatif.co, you will find it. So that's all for today. I hope it was not that boring. And if there is any question, the stage is open.
Yeah, any questions?
So then I have a question, and it's about it's possible to calculate to go forward and back with this calculation between the project, let's say the concept to the calculation. But now I saw the what you do is most think about, I can say, metal and this kind of structure. Do you also this kind of metal for walls and so on? Maybe I didn't saw that, but just to ask.
The metaphor, I couldn't hear.
I mean,
What do you
if I want to calculate also, for example, walls and structure, like I don't know sorry,
Yeah.
but I'm not English as mother speaker, mother tongue. But yeah, if I want to calculate something like walls, bricks, and something like that, it's possible in this way.
Yes. So this building designer is distributed into small apps. So one of them is wall designer, one of them floor designer, one of them connection designer. And those are standalone apps. But the benefit of Awatif is we're going to connect them together. So that's mean if you change the layout, let's say you added the floor, then everything is connected together. Like the load will be propagated where you want to design the wall designer, for example. So you don't need to repeat the process. But answer your question, yes, we have apps for each component for the building. So we are focused on a building. So yes.
Thanks.
Any more questions? Okay. So then we go to the next presentation.